All right, first lesson of the year in algebra. Little do you know, I just recorded this whole lesson and realized that it wasn't recording. So to you, this is take one. To me, it's take two. So maybe it'll be even better this time. All right. This whole week, we're going to solve for x in equations. And at the end of the week, those equations are going to turn into inequalities. So this very first test in algebra is kind of like two tests combined into one, or two standards, I should say. You have to solve for x, and we're going to do inequalities. So there's a lot going on in this test. So we're not going to take it till week 2. We're going to need all 5 days this week to try and learn all this stuff. And day 1 is going to start off pretty simple. It's going to be two-step equations, which you guys did last year. How do you solve a two-step equation? You should hopefully already know that. What's going to take it up a notch here is that the coefficient is going to be a fraction. So you have to, first of all, know what a coefficient is. So say you have this two-step equation right here. 2x plus 3 equals 7. You would subtract 3 to the other side to get 4. And then you would divide by 2. And you would say x is equal to 2. 2 times 2 is 4. 4 plus 3 is 7. All right, I raced through that. I'm going to explain this in more detail and slower here in a minute. But my point is, 2 is the coefficient. The number in front of the variable is the coefficient. The variable is the letter. So 2 is the coefficient. So today, in your problems in the do section, that's going to be your assignment, is you're going to have to solve equations that look like this, but that 2 is actually going to be a fraction. It's not going to be a whole number. So instead of just jumping right into that, I'm going to start from the beginning and try and explain the concept of how you solve for x without necessarily just telling you what the rules are. I'm going to explain to you why the rules are what they are. So let's start off with something simple like x plus 3 equals 7. And right away in your head, most of you probably know that x is 4 because this is a puzzle. Algebra solving for x are all puzzles. They're all mysteries. What is that mystery variable? What number goes in for x to make this a true statement? It's 4. 4 plus 3 equals 7. How do we do that? We're trying to figure out what do we add 3 to make it equal to 7. We add 3 to 4 to make it equal to 7. But if this was a more complicated problem that you couldn't do in your head, you would move 3 to the other side to get x by itself. And what would you do with that 3? Would you add it and say x equals 10? Would you multiply it and say x equals 21? You would subtract it and you would say x equals 4. So why did we subtract it? If I were to ask you why did we subtract it, most of you would say, well, because we added it over here, and when we move it to the other side, we have to do the opposite. It's called the inverse operation. And that's exactly correct, but you're just regurgitating a rule that you've learned to me and not really why we do it. Why do we do that rule? Why does that rule exist? And it's because we're doing the opposite of what we just kind of did in our head. We were saying, what do we add? What number do we add 3 to make it equal 7? Well, if you can't do that in your head, if it's a complicated problem, you could figure it out by working backwards. You could say, well, if we have to add 3 to something to make it equal to 7, that something has got to be 3 less than 7. So we subtract 3 from 7. We're doing the opposite. We're working backwards. So that's why that's why the inverse rule exists, because algebra is basically working backwards to get to that mystery number. What do we add to 3? 4. 4 is 3 less than 7. So that's why the inverse rule exists. You work backwards. All right, let's try one that's now an actual two-step equation. Let's say it's 2x plus 8 equals 14. All right, here's another definition for you. Term. A term is just what's in between your plus and minus signs. So this is a term, this is a term, this is a term. There's 3 terms here. 2x plus 8 equals 14. 2 terms added together equal 14. So these 2 terms, 2x plus 8, you add those together and it needs to equal 14. Well, one of the terms we know what it is. It's an 8. So we got to add, what do we have to add to 8 to make it equal 14? 6. So this whole term needs to equal 6. So instead of doing that in your head, you can just start by getting x by itself by moving the term that we know what it is, the constant, 8, to the other side. And it was adding 8, so we're going to subtract 8. And we're going to say 2x needs to equal 6. And we just figured that out in our head. In our head, we know that 6, this term, if this term is 6, 6 plus 8 equals 14. So that term needs to equal 6. 2x needs to equal 6. So we're working backwards. We know if this first term equals 6, we're good. So how do we get this first term to equal 6? We got to put a number in for 3 that if we multiply, I'm sorry, I just told you the answer. We got to put a number in for x that if we multiply it by 2, it equals 6. So what do we multiply by 2 to equal 6? 3. Simple. You can do that in your head. If this was more difficult and you couldn't do it in your head, you would get x by itself by moving 2 to the other side. And what would you do with the 6 and the 2? You would divide, because we're trying to double this mystery number. So what number do we double? Well, it's got to be half of the number we're trying to get. We're doubling some mystery number to equal 6. So what is half of 6? Half of 6 is 3. So if we double 3, we're good. So x needs to equal 3. So this is just me giving you simple problems so that you can see this in your head, and hopefully it'll make more sense on why we do the inverse operations. Why, when we move a number to the other side, we're doing the opposite of what we were doing here. It's because we're working backwards from our answer. We're saying we know this whole side needs to equal 14, so just this term needs to equal 6, and just this variable needs to equal 3. We're working backwards. We're getting x by itself by moving numbers to the other side and working backwards, doing the inverse operation. Okay, now let's get into something a little more difficult here. X over 2 equals 8. All right, a lot of people every year say the answer to this is 4, which is wrong. The answer to this problem is 4. These are two separate problems. Let me write them next to each other. 2x equals 8. Two different problems, two different answers. This is the easy one. This is 4. 2 times what equals 8? 2 times 4 equals 8. Divide 2 to the other side, x equals 4. This one is not 4. If you say this answer is 4, that means you move 2 to the other side, which is correct, but you divide it, and you said 8 divided by 2 equals 4. That's not right. This fraction here is a division problem. This is saying some mystery number divided by 2 equals 8. So what mystery number, what number do you divide by 2 to equal 8? Well, think of it backwards. We got to find something that's twice as big as 8. So when we split it in half, we end up with 8. So what's twice as big as 8? 16. 16 divided by 2 is 8. So if we can't come up with that in our head, we move 2 to the other side. And since the denominator means divide, they both start with a D. The denominator means divide. X divided by 2, the opposite of dividing is multiplying. So we're multiplying by 2. 8 times 2 is 16. So in this problem, 16 divided by 2 equals 8. In this problem, 2 times 4 equals 8. So that's the whole trick here. If you got to get a number that's in the denominator to the other side, you have to multiply it to the other side. If your coefficient is a whole number, it's still basically a fraction. It's just over 1. And the numerator is your whole number. It gets divided to the other side. So the numerators divide to the other side. The denominators multiply to the other side. All right, let's do a problem that's going to be real similar to what is in the work for you today. And those are fractions that have a number that's not 1 in the numerator. So say like 3/4. So say we got to find 3/4 of x, and we're going to subtract 2 from it, and that whole thing's going to equal 10. Well, let's think about it. We got two terms here. The first term minus 2 equals 10. So what number do we subtract 2 from to get it to equal 10? 12. 12 minus 2 equals 10. So this whole term needs to equal 12. And if you don't want to do that in your head, you move 2 to the other side. And what do we do with 2 when we move it to the other side? We add. Because we're working backwards now. We're saying this whole term needs to be 2 more than 10, because we're going to take 2 away from it. We're taking this term minus 2 to equal 10. So that means this term needs to equal 12, because 12 minus 2 equals 10. How do we figure that out? We move the 2 to the other side, we do the inverse operation, working backwards. All right, so this whole term needs to equal 12. Now we're getting to a point where this is a little more complicated. It's a little bit more difficult to do in your head. So remember, go back to this problem here, 2x equals 4. What did we do with our coefficient? That coefficient was multiplying by x, so we divided the coefficient to the other side. So we'll do the same thing here. We'll divide that 3/4 to the other side. We'll say x is equal to 12 divided by 3/4. Well, how do you divide with a fraction? You flip that fraction and you multiply. So x is equal to 12 times 4/3. And how do you multiply a whole number times a fraction? You multiply the whole number times the numerator only. Because when you multiply with fractions, you multiply straight across, and the whole number is a numerator because it's over 1. So it's 12 times 4 is 48. It's 1 times 3 is 3. 48 divided by 3 is 16. So that's our answer. X equals 16. And that's right. If you substitute this back in to the original line, 3/4 of 16 is 12. 12 minus 2 is 10. All right, let me show you a different way besides the keep, change, flip, moving the whole fraction at once to finish up this problem. Instead of moving the 3/4 all at the same time, you can move those numbers one at a time if you prefer to. So I'll move them one at a time. I'll move the denominator first. So I'll leave the 3x over here, and I'll just move the denominator over there. So what are we going to do with that 4? Well, think back to this example I gave you earlier. X over 2 equals 8. When we moved the denominator over there, we multiplied by 2 because we wanted to know what do we split in half to equal 8. We split 16 in half, so we had to multiply by 2 to get 16. So same thing here. The 4 is the denominator. That's what's saying x divided by 4. So what are we going to divide by 4 to equal 12? Well, we have to multiply 12 by 4 to figure that out. And that's 48. So 3 times what number equals 48? Well, let's figure it out. We're going to move 3 over here. This was 3 times x. We're going to divide by 3. X is equal to 16. So we still end up with 16, but you're just moving one number at a time instead of both numbers at the same time. There is no right or wrong way to do this. Whichever way you prefer. You can move one number at a time like I just did here, or you can move the whole fraction all at once and flip it and multiply like I did in the first time I ran through this. Either way, you're going to end up with 16 both times. So I don't care which way you do it, whichever way makes more sense to you. As long as you're getting 16 as your answer, you're going to be all good. You're going to get 100%. So that's what the problems are like today. Two-step equations with a fraction as your coefficient.